My friends, okay, can you guys hear me through the microphone? Good. So how you guys doing? How was Labor Day weekend? Enjoyed not having a class during that day? Did you say yes or no? Were you kind of like a little worried though? Like I feel sad that you felt relieved from classes. Yeah. So so that was another class gone, but it's not my fault this time, right? But we will be able to catch up. Don't worry about this. We so far this class. You didn't have any assignments, right? Yeah. Sad news. We will have assignment this week, right? So this means you need to have work. You need to get work done. I have uploaded the video for the lecture. Have you seen it? No? Oh. Okay, I have to check this again. Yeah. Did you see it?
No, I didn't
No.
play it, but it was there.
Was it there?
Yeah.
Okay, good. So, please. Sorry?
Where have you uploaded it?
Blackboard. I uploaded it on Blackboard under the content folder. So there is a folder for lecture slides and there is another folder for lecture videos. Right? So this will be uploaded on a... The video will not be on a regular basis. The slides will be right after we finish the slide set that I have for a topic. I'll post it right away, right? So last week I didn't post the slides because we didn't finish the topic, right? So I will post it right after we finish the topic. And the reason I don't post it before is that I encourage you guys to take notes, right? I want to encourage you to take notes, but I'm not going to go to the extreme of not publishing any slides or any videos or anything like this at all. So you're still gonna have the slides, you're still gonna have the videos, but I want you to participate in the class and take notes if possible, right? So this is why I wait till I finish the topic, right? Does it make sense? So the video is there. These slides will be, we already have the slides from last time, a couple of slide decks, and then we have this. Somebody wants to kill me. Yeah. And this week we're going to have an assignment. Last time we talked about horizontal fragmentation, right? And we talked how can we do horizontal fragmentation. We started by the simple example is that horizontal fragmentation is basically each fragment. You partition the data such that each fragment will have a set of rows in the relation, okay? And then it sounded easy in the beginning, but then we ran into situations when we need some properties to ensure that the fragmentation is correct. And these properties, we discussed them last time. We talked about completeness, we talked about reconstruction, we talked about disjointness. We actually had an activity that, remember the CSE 512 Got Talent kind of activity? So that's actually was about these kind of properties. And like completeness, reconstruction, and disjointness. We also had a question from someone in this side that you, right? No, I don't remember. Okay, sorry. So like that said that disjointness and reconstruction, they're not the same thing. There can be something totally different, right? So, but there is an overlap between them sometimes. So you can have one kind of fragmentation that is incomplete, but it cannot be reconstructed and it's not disjoint. So there is an overlap between these properties. The idea is that distributed database system researchers, when they thought about fragmentation, these are the kind of properties that they said is desired for the fragmentation to make sure that you have a good system design, right? And then we talked about like how can we get to these kind of properties? How can, starting from a relation, and we have a workload query coming to a system with a set of predicates run on like that are posed to the system. How can we use this information to decide what kind of good fragmentation, correct fragmentation we can have, right? Remember the example when we gave, like we have a set of simple predicates, and simple predicates are basically, it's just a predicate on one attribute. Either it's an equality, less than, more than, if it's a continuous attribute, or even if it's categorical attribute. It's very simple. We call it, this is why we call it a simple predicate. And then we form from the simple predicates min-term predicates. And min-term predicates are basically like a conjunction of these simple predicates together, or their negation, right? The negation of the simple predicates. And we have endless combinations for sure. Like this is a problem. It depends on the number of attributes, the domain of each attribute that the predicate is applied on. So the computer can use this information, can enumerate the search space for min-term predicates and decide what kind of predicates can make sense, what kind of predicates are duplicated, what kind of predicate from a logic perspective, okay? Predicate logic perspective. So will lead to good fragmentation or not. And then we went through that process and we crossed off some of the min-term predicates. That was all last time. So, and the algorithm we discussed, it was the primary horizontal fragmentation. And primary horizontal fragmentation means that you have, again, theoretically, you have a relation or a table, and then you partition the table based on the min-term predicates that you get from all this kind of logical expression that we explained last time. Okay? So why it's called primary horizontal fragmentation? There is a reason, and we're gonna, in a few slides, you're gonna see another kind of horizontal fragmentation that is not primary. This is why this one is called primary. It's just a spoiler alert, so it's called primary because the fragmentation is done on predicates that are applied to a primary relation, the primary table in the database, right? So having said this, so we will have our first assignment. And assignment 1 is about how can we do fragmentation on the data. So basically in the assignment, you're gonna download a data set, and the data set is a movie ratings data set. So movie ratings, the data set, it's stored in like CSV files like this, and this is an example of the data set. So as is like this, it doesn't make sense, but each record, you have 4 records here, and each one is separated by 2 columns, okay? So the first record represents a user. This is a user like you when you watch Netflix. And the second attribute represent a movie, okay? And the movie that you as a user watch on Netflix. And the third attribute, which is like the first one, for example, here is 5. This is a rating that you as a user gave to the movie after you watched it. The last attribute is a timestamp. When did you give this rating to the movie, right? So on and so forth. You have so many of these lines in the text file that you're going to have. You're going to find the data in. So I just explained to you the logical meaning or the conceptual schema and what does it mean here. So this database is from a system called MovieLens. It's a movie rating database, but it's not Netflix. It's something similar. It's an academic data set by the folks at the University of Minnesota, and it has like thousands of movies, thousands of users that have been rating movies. And the idea is that we want to look at this data set and we want to take it and apply some kind of fragmentation on it. All right? So how can we do the fragmentation? What do I exactly want you to do on this table? First off, this data will be loaded into a database. The database system we're going to use is Postgres. How many of you heard of Postgres before? Good. Yeah, like classes a few years ago, a lot of people didn't hear of Postgres, so now a lot of people know about it. It's good. So Postgres is, for the few of you who do not know what that is, it's an open source database system, relational database system. And it's similar to MySQL. MySQL has more popularity, used to be more popular. If you dealt with any relational database before, any system that allow you to interact with data using SQL, right? And you can store data in the relational schema. So Postgres is that way. And it is a centralized system. So it's not a distributed database system. So what we're going to do is that we want to partition or come up with a fragmentation on top of this data. So there are two ways that I want you to perform the fragmentation on this kind of data. The first way, we call it partition the rows and put them in fragments based on values in a specific attribute. One simple predicate. And this predicate is the rating. Okay. So I want you to take a look at the table. You're going to have a table that has 3 attributes or 4. User, item, and a rating that the user gave to this item. These are 3 attributes, numerical attributes. 2 of them are integers and 1 is a numerical attribute. So I want to partition or come up with a fragmentation that partitions this table based on the rating attribute. We call this range partitioning. This is the first way I want you to do it. So basically you're going to have the table, and then based on the number of partitions you're going to decide the boundaries and how many tuples exist in each fragment. Sounds good? The second fragmentation, or the second way we're going to do the fragmentation, is called round robin. And this is even easier, right? If you've taken any computer science class before, you probably know what round robin means, right? So round robin means while you have the table, you take each row in the table one by one, and you put it in fragment 1, fragment 2, and the second row in fragment 2, third row in fragment 3. Depends on the number of fragments you have, right? And you go in a round robin manner that way. So over all the fragments. So if you have 10 fragments, you add row 1 in fragment 1, and row 10 in fragment, and so on and so forth till row 10 in fragment 10. And then row 11 in fragment 1, and then keep going that way in a round robin fashion. So this is the second way I want you to do it. So this is basically I cut and paste from the instruction document that you're going to receive today for your assignment. So basically you're going to do one function called the range partition, another function called round robin partition. And not only this, after you do the partitioning, I want you also to allow for inserting new data, but you insert into the right fragment instead of inserting in just one original table. I want you, after you do the fragmentation that way, whenever you receive a new tuple, you insert it in the right fragment. So this is why you have round robin insert, you have range insert. Okay? So the main idea here, we're trying to simulate the fragmentation. You're going to have multiple fragments, and each fragment, of course, is going to be represented by a separate table on your end in the database. And the naming for the fragments and all these kind of things, you can decide it. It's fine. It's again, I want this to be transparent from the end user. I will be the end user, the person grading this, be the end user. I will try these functions. I will see whether they work properly or not. All right? So this is basically the first assignment. And you're going to have an instruction document you're going to have a script that have the interface for these functions with all what is the input to these functions, the function prototypes, okay? And all what you need to do is that fill in the interface. Also, we're going to release a virtual machine, an image for a virtual machine, so for all of you to use as the environment, programming environment for you. So when we release this image, you're going to take it, install it on whatever your laptop or any computer, and it will have Postgres installed. It will have the right Python version because you're going to implement these functions in Python and connect it with Postgres, okay, in the database. So it will have all of this environment for you so that nobody will ask questions about which Python version we're going to use, which Postgres version we're going to use. We're going to have all the same version in the same virtual machine, right? And we're going to do the grading on the same virtual machine. We're going to distribute to you. However, this virtual machine, we're going to have it probably tomorrow released to you. So you can start working on the assignment tonight if you want to. And then later, this virtual machine just for compatibility. You know, it's nothing more than that. So we're going to release the scripts today anyway. You can install, play with, think about the problem. And then we're going to release the virtual machines probably tonight or tomorrow. Okay? One thing about the assignment, we are going to grade for correctness. Okay? But if one function we run sometimes and it takes a lot of time, we're going to get really bored. We're going to cancel the job and move on to grade other person, right? So make sure that you make your code very optimized, right? None of this is super complicated or anything like this. Okay, it's straightforward programming. If you follow the straightforward optimization techniques for your program, you'll be fine. There's nothing sophisticated, okay? So why I'm saying this? Because again, grading for the large class, it's going to be a little tough to run the program and wait, and then think of if you have 150 students and then each program will run for 30 minutes, the test case. So how much time this will take? Forever, right? So we're not going to have time to finish anything. So you might ask me, why don't you run this on a cluster and parallelize across everyone or something like this? All right, we may do that, but I mean, we may not have the resources, okay, to do it. So this is for the assignment. Again, I'm just introducing the assignment to you so that you have an idea, but there will be more details again in the scripts, and you have a Python script and everything that will give you more idea. And again, the full instruction document that has this information will be released to you as well. Okay? Sounds good. Any questions? Please. Wait a minute. Can you please yell at me?
Are you gonna tell us how much max time it's gonna take to run a job? Because you said we need to write as optimized code as possible. So are you gonna give us a limit so that your code should run within this time?
I'm not gonna give you a limit. No, there's no specific limit. But if your code takes 20 minutes or something like that, there's something wrong, right? So the code should run in, at most, the hardest thing, the slowest thing should be few minutes, like 2 or 3 minutes or something like that, okay? It's the slowest function in here, okay? And usually, again, when you do insert, this will be like in very fast. It's not even a minute, it's in milliseconds, okay? So I'm just saying, okay, because we're going to run test cases and all this, we don't want to get stuck in one program. All right, so please.
Will the instruction document carry the submission format?
Yeah, we also have, as I just mentioned, we have these functions. We have a script, a Python script that have the interface, like the function prototype, with the naming, like what is the name of the function, what is the name of the variables, and everything. And you're going to take that and plug in your code in it. So you're not going to And this interface was tested already on our solution, right? So yes, it will have more details on, and it will have code with it that you just need to plug in your solution in that code. All right? Please.
Do we have access to the test suite that you're running?
We'll have some test cases for you, but not everything. All right.
So will you be running will you be checking it for the same data set or a larger data set?
Larger. All right.
Just a correction. Is it like range partition, the second one should be round robin partition?
Yes, round robin partition. In the document, it will be correct. Okay. Sorry about that. You're right. This is a mistake here on the slide. Okay. But it will be round robin partition. You're right. Yeah. Okay. Let's move on. Okay. So we talked about the primary horizontal fragmentation. Now it's called primary because there is derived horizontal fragmentation. And derived horizontal fragmentation is basically you don't have just one relation. You have two relations, and one of them defines the way you do the fragmentation. The other one is just the one you do the fragmentation on. It's a little bit confusing, right? So we have a link, and the link has a member relation and an owner relation. Okay? This link is basically there is an equijoin between the owner and the member relation. And based on this join, you do the fragmentation for the member relation. Let's take an example, okay? So here we've looked at the schema before. We have multiple tables. One of them is the pay table. And the pay table has basically, based on your title in the company, what is your salary? Very simple table. And you have an employee table. And the employee has just the list of employees in this company, as well their name and their title, each employee's title. You have project and you have assignments also. If I want to partition or to do the fragmentation for the employee's table based on the employee's salary, how can I do that? I don't have the salary information in the employee's table, right? So in this case, I have to go to the pay table to get this information from. So this pay table is the owner relation. It's called the owner relation because it owns the attribute I'm doing the fragmentation on. And the employee is the member relation in the link. This is the relation I'm doing the fragmentation on. Make sense now? So in this case, to do the fragmentation, first you need to go to pay, do the fragmentation based on the salary. As you're going to do in your assignment, you're going to do range fragment, like for all employees with a salary in a specific range, you put them in a fragment, other range in another fragment, and so on and so forth. And this is again for the pay table. You still didn't do the employees. You just did the pay partition table. And you want to actually do the fragmentation on the employee. This is why you need to do the equijoin between the fragments you created from the pay with the employee so that you get the final employee fragments. That's a theoretical definition of what I've just explained to you. So basically you have a link. The link has an owner and has a member. And what you do is that the fragmentation is basically an equijoin between the owner and the member on a specific fragment of the owner. Okay? So you get, this is how you get the fragments for the members, right? So this is basically the idea. So again, following this example, you have the owner here is the pay, as I just explained to you, and the member is the employee table. And you get the first fragment of the employee when you equijoin the whole employee table with the fragment from pay 1, and employee 2, you get it by equijoin with pay 2. And pay 1 and pay 2 are actually just 2 fragments, and each fragment has salary less than 3K and the other one salary larger than 3K. And eventually, the fragmentation of the employees will look like this. Employee 1 will have all the employees with less than or equal 3K salary, and the other one more than 3K salary. And this is the derived horizontal fragmentation. Does it make sense? Right? Nothing complex here, right? So, in that sense, how can we achieve 2 important properties, which are completeness and disjointness, in this kind of fragmentation? So how to get completeness? What kind of constraints we need to have on both the owner, on either the owner or the member relations in the link to achieve completeness, for instance? What do you guys think? What kind of constraint we need to enforce, the database need to enforce on the owner and the member relations?
The owner fragments should also be complete.
The owner fragments also needs to be complete. Okay, and this will ensure that we have full completeness for the final fragmentation for the member. No, but this is necessary too. But this is not what's going to make this complete eventually. Please.
Adding on to that is required, and the primary key of the owner has to be compulsory to be. I mean, it has to be not null in the.
Has to be what?
Not null.
The primary key is not known, right?
No, it does not have to be not null in the child.
What does that mean? Yeah.
It has to act like a foreign key.
So hold on that. So what do you think? Yeah.
Every row in the one that's not the owner has to join with at least one fragment of the owner fragment.
So every row has to join with at least one. What does that mean? I want to just both of you said something actually very similar to each other, but you don't realize that. So in database systems, when we have a table and we want to have like at least one row exists in the other table, what does that mean? What's that? Yeah, primary key, foreign key, right? So the owner, you need to have a primary key, foreign key relationship between the owner and the member to make sure that this condition that you just explained happens, right? So we call this in database system a referential integrity constraint, okay? So if we enforce referential integrity between the member and the owner, we make sure this is complete. Otherwise, no. It's not going to be complete. We cannot ensure that. Do you guys understand now, right? Yeah. So basically, referential integrity constraint is the key here to achieving completeness. So the join attribute of a member relation and the join attribute of the owner relation. All right. So to get this jointness, what does it mean? How can we get that? What is the condition, again, the constraint, that if it does not apply, we cannot ensure disjointness? Anyone? Any takers? What if the join attribute of the owner relation. The owner relation here was the pay. Please.
It should match to the only one record in the master. It should match to both the salaries. One with 3,000 above and one with 3,000 below. Then it will be making duplicate record and it will be running both the records.
It should be unique,
Yeah,
right?
it will be unique.
In the owner relation, right? That's a condition or a constraint. If you don't have, you cannot ensure disjointness. Okay? So join attribute should be a key for the owner relation. Otherwise, it's really hard to achieve disjointness in this case. Please.
The joint attribute mean the key of the owner and the member.
The join attribute is the attribute you do the join between the key and the member. Yes, which is the primary key, foreign key kind of thing. Like if you go back here, what is the join attribute here? Title, right? So title has to be a key in pay to achieve disjointness, right? Otherwise, you can never achieve disjointness. You cannot ensure you achieve disjointness. And you must have a primary key, foreign key relationship, referential integrity between the join attribute in owner and the member to achieve completeness, which is actually applies here. So the foreign key is the title in the employee table, and the primary key is the title in the pay table. I believe this makes sense, right? It's just like if you try to change that and you figure there's a problem here. All right, so please.
In that example, primary key must be unique in my understanding. But in the table student, we actually refer to title, and title could be like two person have the same title.
Yes, we're talking about it's a key in the owner relation. Yes, two persons have the same title in the employee, which is the member relation. I know it's a little confusing, member and owner, what is the member, what is the owner? Again, think about it that way. So the owner owns the fragmentation, like the way you do the fragmentation. The member is actually the actual table you fragment. Okay? So the member follows the owner, the way we do the fragmentation from the owner. That's basically it. Vertical fragmentation. So we talked about also how can we fragment the table or the relation vertically. So, and this is an example. We've seen something similar to it. You have an employee, and then you can have it in two fragments, employee 1 and employee 2. And each one of them has a different set of attributes. Okay? But we have one attribute that is common here. So vertical fragmentation is usually more difficult than horizontal because you have more alternatives. And there are two approaches, two algorithms you can use, two kind of family of algorithms. One of them is to start from the attributes and then you cluster them into fragments. And the other one is basically you start from the relation and then you split it into fragment. So it's like a bottom-up or a top-down approach, pretty much. Okay, and each one has different pros and cons. So also other properties we need to take into account is completeness. And completeness in this case is when you union all the attributes. Okay, this is actually the attributes of the original table that you have. Another thing is disjointness. Disjointness in its pure form, which means there's no duplicates whatsoever. Is it a desired property here or no? Why not? you cannot reconstruct the original table, which is a really important property. So this is why if we did here we did the fragmentation, and it's right, all the attributes exist, but you could not reconstruct R. So this jointness in its just pure sense that way, it's not desirable when you do vertical fragmentation that way. So the property again is lossless join. That's the property we're talking about for reconstruction. So if you join all the fragments together, you can get the original relation. And that's a relational operator that if you apply to all fragments, you can reconstruct the original relation. So in this case, reconstruction is applied. Yes. So also for vertical fragmentation, okay, how can we decide which fragments can go together or not? There are so many ways. One way we try to find proximity or affinity between attributes. So everything inside the database, in order to make it efficient, you need to take into account the workload. The workload is the queries that are applied to the database. So you have a set of queries coming to the database, and each query is accessing a different set of attributes, assuming you have one table, for example, one relation. Okay? So if let's assume the query is looking for is using the attribute. Using the attribute, that means in the SQL, this attribute appears in the where clause, for instance. Okay? Select from this table where salary is equal to X. So salary appeared in this query. It appears, you have like a Boolean that says whether this query accesses this attribute or not. So this is use, you have Q and A. So A is the attribute, Q is the query. And based on this information, for all queries you have, let's assume you have a workload, you can have an attribute usage matrix like this. For each query, and these are example of queries, Q1 to Q4 that you have here. If Q1 used attribute 1, we have a 1 in the matrix. If it's not, so we have a 0. So we have this whole matrix called the attribute usage matrix. And you can guess based on this attribute usage matrix, you can decide which attributes to put together in the same fragment. So if attributes are accessed together, you put them together. The simplest way to look at it. So there are so many ways to do that. Like one way is to basically have like attribute affinity measure between two attributes. Okay. This affinity measure basically is that calculate how much two attributes are close together, if they're accessed together or not. Okay? And the other one is just to normalize this value. So after you calculate this, and there are so many ways to calculate, this is just an example. You might also have other ways, like for similarity measures, cosine similarity, or you can have Jacquard similarity, any kind of similarity between these two vectors of the attribute based on the query axis. And you calculate something else called the attribute affinity matrix. So you have the query attribute matrix we had here, and this is basically whether each query accesses this attribute. Based on this, you have these kind of, for each attribute you have a vector, and you can calculate the affinity between pairs of attributes based on this vector. Okay, based on this matrix. And once you get this value, which is the affinity between attribute 1, attribute 2, or each pair of attributes, you store it in a matrix called attribute affinity matrix. So again, the attribute affinity matrix has attribute to attribute value, and the values here is the affinity measure that we calculated. So based on this, what kind of attributes you guys think should be put together in the same fragment?
A4, A5.
Okay, give me A1, A2.
A4, A5.
So A1, A2 alone, and then A4, A5 alone, or A1, A2, A3 in one fragment.
Yeah.
So what about A4 and A5? So let's think about the first fragment first. A1, A2, and 3 in one fragment. Who agrees on this? Okay, we have quite a few. And why do you think we should put A1, A2, A3 in the same fragment? Based on this. Please, yeah, go ahead. Go ahead. Yes, you. Yeah.
Because there's a large chance that they access A1 and A3 together.
Because the affinity between A1 and A2 is high, and the affinity between A1 and A3 is high, and the affinity between A3 and A2 is high. So all of them can actually be put together in the same fragment because they're all accessed together, pretty much. What about A4 and A5? It's actually the same. So A4 and A5, the affinity between these two attributes is high. So we put them together as well. So in this case, you can tell from this matrix that the two fragments that we can have are R1 and R2. And again, we have K replicated, which is the key attribute. And you guys already know why, right? To achieve reconstruction and have the lossless join property. Does it make sense? How to calculate the affinity is, there are so many ways to do it. We just explained a very simple way. I gave you other similarity measures maybe. But again, there are so many ways to do it, and it depends on your application as well. Okay? How can you, is the fragmentation done solely based on query access? Not really, not all the time, but query access is a very important factor, right? And other things you might think of, and we're going to talk about this later in the course, is also how can you do load balancing. Please, yell at me, please. Yell at me.
So my question is like when we are
I can't hear you. Yell at me, please. I want to be scared.
okay,
Yeah.
my question is like this attributes, these are all of the member relation or like it is like the whole join set of like which includes the owner relation?
There is no owner member here. This is vertical fragmentation. We're moving away from this. Let me tell you. So first, I'll tell you the story of the fragmentation from the beginning. Okay? First, we discussed we have two kinds of fragmentation: horizontal and vertical. Horizontal means you partition by rows, vertical partition by columns in the table. In horizontal, we discussed two main ways to do it. One way is called primary horizontal fragmentation, okay, which is you fragment the relation based on attributes of this relation, right? So into rows. And the other one is derived, which has the member and the owner. And you also still do it horizontally for the member relation, but based on information from the owner relation. We finish horizontal, we then move to vertical fragmentation, which is partitioned by columns, have a set of columns together, like vertical, okay? And when we did this, we said, okay, columns means attributes. Each column is an attribute of the data. We calculated this attribute affinity matrix, and based on the affinity between each attribute, based on the query access, we decide which ones to put in the fragment again. This is the whole story in 2 minutes, I guess. Right. Okay.
Yeah, so if
Makes
I
sense?
got confused because can you discuss this portion after
Yes, sorry, my bad. I move fast, I know. Whenever I move fast, just stop me. Yeah. Other questions? Good. All right. Please. I didn't hear a word. Okay, here's what I've heard. That's what I've seen, right?
In the vertical
Yell at me. I want to be scared. Please. Yeah.
In the vertical fragment,
Yes.
there's the type of splitting that's done. So it's like relation to fragments. So what is that exactly? The relation between attributes?
In the vertical fragments, are you talking about this matrix or?
No, this grouping and splitting, right?
Yes. So this is just to, good point. So what we meant here is that there are two family of algorithms to do that. You either assume that you have fragments and each fragment is one attribute, it's one column, and then you start building fragments from these attributes, larger fragments. Or, and this is, think of it as a bottom-up approach. So everything is scattered, and then bring the attributes together, put them in one fragment, two attributes, three, one fragment, okay? Bottom up, okay? So this is this one. Yeah, the grouping, exactly. So the other one is the splitting. You start from a relation, and you keep splitting into fragments and to see what's going on. So this is basically the idea. I want you to speak that loudly all the time. Good job. Yeah. All right.
One more question. Can we call this as grouping? Because we are grouping A1 into A3 irrespective of.
Yes, we can call this grouping. Yes. All right. So I just said the story of the fragmentation. Can we do all these fragmentations together, horizontal and vertical, or no? Yes. So you can do you can mix them up if you want to. So you can start that way, look at this tree. So you can start from a relation R, do horizontal fragmentation, get R1, R2, take R1 and do vertical fragmentation and do R1, 1, R1, 2. And then for R2, you do vertical fragmentation into 3 vertical fragments. So you can definitely do that. And you can have multiple layers of these, multiple levels in the tree. Very simple. Okay, so the other problem is that now you did fragment the data. And we said that fragmentation is necessary in distributed database systems because you want to decide if I have multiple sites, what data to put on these sites. I'm not going to have all the data put on every single site. Maybe, but if I'm not going to do that, how can I decide? So fragmentation was necessary, but fragmentation is a logical operation. So you did not actually see any, okay, I didn't say, let's take this fragment, and this fragment was on this machine or on this computer or anything. I didn't say any of that, right? So it's a logical operation. The operation that is responsible for doing the physical storage of these fragments in the sites, in the computers that are spread across the network, is called the fragment allocation. So fragment allocation is a more complex problem, actually. So basically, you have a set of fragments. We already done the fragmentation. You have a set of network sites. These are the servers you want to store the data in, but we just call them for generality network sites. And you have a set of applications, which are queries, accessing the data. And you want to find the optimal distribution of F, the fragments, to the sites based on this information. So if you've taken any optimization course before, so you want to minimize the cost. We're going to talk about what we mean by minimize the cost a lot during the course of the semester. So you want to, for example, first of all, you want to minimize the latency for all the applications, all the queries. Latency means the time that the user asks the query till the time the user receives the answer. You want to minimize this time. And to do that, you want to minimize communication cost, storage cost, access from storage, I/O cost, and processing, CPU and memory and all these kind of things. So also, the performance here, what we mean is the response time. Sometimes even if you made the communication time less, that does not necessarily reflect in the response time. Response time is more of a user request. So you want to minimize the response time, and also you want to, a very important factor in systems is the throughput of the system. Throughput means like how many requests you can access per second. How many, if you have a set of queries coming to the system and a set of updates coming to the system, how many of these you can run per second? That's a throughput of the system. That's also, you want to increase that. And you have, again, constraints. And the constraints can be per site constraints. You have limited storage for each site, like how much storage, how much memory, how much CPU. So how can you, so given all the constraints and all the optimization parameters, so this is a multi-criteria optimization problem with a lot of constraints. So, which means it's a hard problem. It's a very hard problem. However, we managed to go around this whatever integer linear programming or multi-criteria optimization issue, that different problems we're talking about here, and we always look for ways for heuristics to solve this kind of problem. Again, there's no single answer to which fragment, how to allocate the fragments. However, there are priorities in systems. Like in some systems, people focus on, they want to minimize the latency. And they don't care about any other things, as long as they minimize the response time for the system. Other people focus on the throughput, optimize for the throughput. Other systems optimize on something we call load balancing. How can you have a load balanced? We're going to discuss many of these issues during the course of the semester as well. There are other issues with the problem. It can be actually more complicated, like where the queries originate. So where do you have the queries from? So if you have multiple sites and you have an application like Facebook, so you want the fragment that has my information when I live in Phoenix in the Phoenix server, right? As opposed to other people, someone living in Beijing, right? So they want their Facebook information fragment is in Beijing. You might have fragments of people living in different areas. How can you optimize that? Okay, so this is also another problem. Again, per site issues, the size of the answers and sub-answers between the queries, and processing power at each site. This is also, we already discussed that. Another issue is that sometimes, once you have fragments, sometimes you may decide, as a system administrator or the person who designed the system, to replicate these fragments. Why sometimes we need to replicate fragments? First of all, do we replicate fragments? Yeah, the answer is yes. Sometimes we do. So why do we replicate fragments? What do you guys think it is? So I want you to do a small activity now for just 3 minutes or something like that. And again, talk to your neighbors. I want you to come up with reasons why replication, if we need to replicate data or fragments. And when does it become challenging? That's the second question, to do the replication. All right, folks. That's enough talking. So, why replication? Just by show of hands, okay? So, gentleman in the back.
So, we get usually two applications for queries. One is load balancing. Second is if we have higher read queries. And third, if we have higher write queries, so that we wanted to decrease the latency. And for increasing the availability.
Did you guys hear anything here?
No.
Who like you heard it?
Yeah, we heard it.
Okay. But somebody said no. Yeah. So even though she's closer. Yeah. Can you please say it again? But in a louder voice, please.
We need replication for load balancing. Second, if we
Load
have-
balancing. First reason is load balancing. Can you explain what you mean by load balancing in this case?
Okay, so let's say if we have a data center which serves like million of requests. So if we replicate our data center, then we can divide our traffic into two.
So you load the balance for the traffic. All right. So the other reason.
If we have higher write, if we have more read queries than write, then it would be good if we have like separate data. It basically decreases the latency which user might face, and all I can think of like when does it become.
All right. Thank you so much.
Question.
She has a question, please.
How does replication help in load balancing? Replication.
We're going to talk about it. I'm just taking answers from people now, but coming back to you. Don't worry. Yeah. Please go
To
ahead.
avoid single point of failure.
What is that?
To avoid single point of failure.
To avoid single point of failure. You have another answer.
Fault tolerance.
Fault tolerance, please.
You mentioned that you had like data in Phoenix, so what if you have less location-specific data and you want to replicate it all over to decrease latency?
To decrease latency, if you have.
So if someone wanted to access data that wasn't in the US, they wanted to access your Phoenix data, we want that replicated somewhere else so they would get that information faster.
Yes. Okay. Makes sense. Okay. So other answers, please.
So if there is like a Facebook, so we need the initial copies first, and then we need to load the full profile. So we can replicate the data like that the initial copies comes first, and then we need the full profile or something like that. So user can just see initial copies, then the other copies will just like load. So for that we can replicate the
Replicate
data.
some fragments that
Yeah.
are accessed in
Yeah.
a lot or something like this.
Yeah.
Okay. So pretty much everyone said something correct here, and I'll take the last one here, please.
When we are using a distributed database system instead of a centralized,
When you use distributed database system, what's going to happen?
when we are not using a centralized server and when we are using a distributed one, so the data availability is there.
Data availability. Okay. Sounds good. So, perfect answers. So the main reason people do replication, there are many reasons, but the main reason is availability. Remember when we talked about availability was last week, right? What did we say about availability? And I like that people mention an example from Facebook, because we can always relate to examples in our daily life. Availability means at any time you have, it doesn't need to be a database system, right? I'm talking about any service provided to you. If you access the system, you can access the service at any time as a user. Why replication will help you achieve more availability? Because if you have a lot of users accessing the system, and they're all accessing the same data, and the data is not replicated, this means you have to direct the request to one location every time, to one unit, one site every time. This site can go down. Let's assume that the site will take only 1,000 requests at a time. If you have 1,001, you're done, right? It will go down. But if you replicated the data in another site, and the other site takes 1,000, another 1,000, so you can have the system more available. So availability is the key when it comes to replication. This is like replicating the data across multiple sites, this is basically the idea behind. However, there are other perks. So you mentioned faster query response time. Yeah, because availability can lead to faster query response time as well. So if you have, again, one server, one site, who receives the 1,000 requests, in order to get more requests, you have to put them in a queue, right? And run them. But if you have data replicated at multiple sites, you may not need to wait. So this means response time is even better. Even the system will not go down, but it will be faster also. That way. And again, you can relate to Facebook that way. And you can relate more to Amazon. All right? Or Snapchat. Snapchat is a cool thing these days, right? Isn't it? You guys are old like me, right? You don't know Snapchat. Yeah. Okay. So fast availability is number one, and faster response time. Okay. So when does it become challenging? We'll take gentleman in the way back at the left. Yeah. At my left.
We have a limited storage. When we have a limited storage,
yes.
And while synchronizing the data, if we have data at multiple points, while synchronizing
limited storage. Okay, I'll take that from you. Okay. So limited storage. That's one reason. Gentleman here.
When you write more than you read.
When you write more than you read. Okay. Other issues? Consistency. Okay. Please. Synchronization. Okay. Please.
So
One
the
more.
cost to transfer the data to another machine.
Cost to transfer data to the other machine.
High maintenance.
High maintenance. Okay. Please.
Avoiding duplicates become harder.
Avoiding duplicates become harder. Okay. So there are so many words that you said here that all resort to just one word eventually, like one thing eventually. So it becomes challenging. As the main reason it becomes challenging, of course, you can think, as John said in the beginning, storage costs. You have, instead of having one version of the data, of the fragment, you have two. So you have to store that. Okay? So that is an issue. That is an overhead. It is a minor overhead though, okay? But it is an overhead. Why minor overhead? Because it's cheap to store things, right? It's not like a super big issue. It can become an issue if if you replicate the whole data 100 times. Yeah, I agree with you. But otherwise, yes, it is an issue, but it's not. It's a minor issue. The main issue, as the gentleman mentioned here, is updates. And you guys talked about consistency, synchronizing the replicas, all of these problems, high maintenance, all these kind of things is because of the updates. If you have no updates whatsoever, replication is perfect. Maybe the cost of the storage is the issue, but that's not a big deal. Okay? But if you have updates, problems will start to arise. Why? Problems will be, why do we have problems with updates?
Multiple keywords at same.
Show of hands, please. Please at the back.
Read-write errors.
Read-write
Errors.
errors. Okay. Please.
You have to write a lot of.
Write a lot of locations, right? So take time. Okay, please.
That's what I was going to say. I'll say it.
Please. Thank you. Please.
Providing latest update to users. Again, if it reads again.
Latest updates, how can we get that? Please.
We need to keep track of which locations the data has been replicated.
Keep track of the location of the data if we replicate it. You have a question here, or you have a question?
Does the centralized system
Loud and quick.
centralized system will incur the cost where you need to replicate fragments and it has to duplicate data or
So maintaining duplicate data is an issue, right?
yeah, so does it incur a cost in centralized system?
Yes, absolutely, absolutely. So all the answers are correct again, perfect. So when we have updates, in a centralized system, as she mentioned here, we had an issue keeping the database consistent anyway, right? We have concurrency control, we have transaction management, we have when you have reads and writes and you have multiple transactions accessing the system. Please. Yeah. So when you have multiple transactions accessing the system, so how can you keep that? Because that was a big deal in a centralized system. What if you have a distributed system and you have rights to the data items, and these data items that you struggle keeping consistent in one centralized machine or one centralized system, now you have to deal with the replica of this data across multiple machines. If you have people writing in this data, okay? And you want people to read from all the replicas. So if you don't update all the replicas, people may read different versions of the data, and this will make the database inconsistent. You don't want this to happen. Or maybe you do in some applications. We will see later different levels of consistency in the database. So replication with updates is an issue. And also, one can say is that once I have an update in one replica, I will go ahead and make sure before I commit this update, I make sure that all the replicas are updated. This way you make sure the database is consistent. But what about the response time? Do you want to wait till you update all these replicas, till you give the okay to the application? And if you have a lot of these, what you're going to do? So it is a challenge, right? She's right here. So having replicas, and if you have a lot of transactions, a lot of writes into the system, it will become really hard to keep the database consistent. And again, we will have a lecture or two maybe on how to keep database consistent in the existence of replication in the database. We will talk about this in way more details than this, right? Perfect. You guys are great. Yeah. Not yet. Did I say like let's go or something? I said you guys are great. I mean that's it's like that doesn't mean anything, right? Yeah. Okay. So updates are challenging. So also don't worry, just a couple of minutes, okay? It's just like I know like you wanna I'm standing between you and dinner probably, so just give it a few minutes and you can have dinner. Okay, so also you're going to have potentially improved performance, especially if you replicate data and their proximity to where they're accessed, okay? And that was mentioned here also. So if your Facebook profile is here, but also your friends some of them are here, some of them are in like whatever, Bombay or something, so maybe they replicate the data in Phoenix and Bombay, right? So it depends on, because your friends will access your data and you will access your data here. So replicating based on where the data is accessed. So again, the optimization problem we talked about in allocation and replication. When you have also replication, so how can you assign replicas to sites? That's also another issue. Are you ready? You guys ask questions and you want to leave, but just one last thought I want to leave you with. Project. We will release the instruction document for the first phase of the project pretty soon. Meanwhile, each group, please start doing that. Start doing that means like playing with Apache Spark. Apache Spark is not a proprietary, like it's not an IP kind of system. You can still download and play with it. There's a lot of tutorials online. Okay, please do that. If you don't do that, you're going to struggle with the project. Please do that. Okay. You have a question? The assignment will be due. The assignment will be released tonight, and it will be due in a week. You have 1 week to finish the assignment. Thank you so much.